Gradient descent is one of the most important algorithms in machine learning and artificial intelligence. Nearly every neural network you have ever interacted with, from image recognition to large language models, was trained using some form of this technique. Understanding it means understanding how machines learn from data. To improve the model, we first need to measure how far off its predictions are. A loss function, also called a cost function, takes the predicted output and the true label and returns a single number representing the error. The closer that number is to zero, the better the model is performing. Training is the process of making that number as small as possible. The training objective is an optimization problem. Find the set of weights that minimizes the loss function. In theory, you could try every possible combination of weights, but with millions of parameters, that is computationally impossible. We need a smarter strategy, and that is exactly where gradient descent comes in. Gradient descent is an iterative algorithm with 3 repeating steps. First, compute the gradient, the slope of the loss with respect to every weight simultaneously. Second, move each weight a small amount in the opposite direction of its gradient. Third, check if the loss has decreased and repeat. Over many iterations, the weights converge toward values that minimize the loss. The core equation of gradient descent updates each weight by subtracting a fraction of its gradient. The symbol alpha is the learning rate, a small positive number controlling how large each step is. The gradient of the loss, written as del L, tells us the direction and magnitude of the steepest ascent, so subtracting it moves us downhill. Gradient descent requires the gradient of the loss with respect to every weight in the network. Backpropagation is the algorithm that computes these gradients efficiently using the chain rule of calculus. It propagates the error signal backward through each layer, computing each weight's contribution to the final loss. Together, backpropagation and gradient descent form the foundation of neural network training. Gradient descent reduces a profound question: how does a machine improve from experience to a precise computable answer? Measure the error, compute which direction each parameter should change, take a small step in that direction, repeat. This simple loop, executed billions of times across millions of examples, is how machines learn.